morning students, this is Sheba. Now we are going to discuss about the electronic devices UNIT-5, power devices and display devices. In our previous session we have discussed about the power devices such as MOSFET, diac, triac, VMOS, DMOS, and also display devices like LCD display and LED display. In this session we are going to discuss about the phototransistors. What is meant by this phototransistor? It is a semiconductor light sensor formed from basic transistor with a transparent cover that provides much better sensitivity than a photodiode. You can see the pictographic representation of this phototransistor and its symbol. It has two legs, namely emitter and collector sides, and photons emitting arrow mark symbols are also given in the picture. This phototransistor, as I have said, it is a 3-terminal with emitter and collector ends marked clearly. The phototransistor is a three-layer semiconductor device which has a light-sensitive base region. The base senses the light and it converts it into current which flows between the collector and emitter region. The construction of phototransistor is similar to the ordinary transistor except that base terminal. In phototransistor, this base terminal is not provided and instead of the base current, the light energy is taken as the input. Moving to the construction of phototransistors. The construction is quite similar to the ordinary transistor. In earlier, germanium and silicon are used for fabricating the phototransistor, and the small hole is made on the surface of the collector base junction for placing the lens. The lens which focus the light on the surface, which you can clearly see from the diagram. P base region and N collector region is doped, in which between the two N plus region the light photon gets emitted. Moving to the principle of these phototransistors, consider the conventional transistor is having open terminal base circuited. The collector base leakage current acts as a base current ICBO, where IC is equal to beta into IB plus 1 into 1 plus B into ICBO. As base current IB is equal to 0, it acts as an open circuit and the collector current becomes IC is equal to 1 plus B into ICBO. From this equation we can say that the collector current is directly proportional to the current base leakage current, that is the IC increases with the increases of collector base region. When no light falls on the surface of the transistor, what happens? The small reverse saturation current induces on the transistor, and this reverse saturation current induces because of the few minority charge carriers, and also the light energy falls on the collector base junction and generates the majority charge carriers, which adds the current to the reverse saturation current. From the graph given below, you can clearly see the magnitude of current increases along with the intensity of light. The graph is drawn versus base current and illumination level. The phototransistor is widely used in electronic devices like smoke detectors, infrared receivers, CD players, lasers, etc. for the purpose of sensing the light. As I have said, moving to the advantages and disadvantages of phototransistor. Phototransistor have advantages like it produces a higher current than photodiodes, and it is relatively inexpensive, simple and small enough to fit several of the transistor in a single integrated chip. And also these phototransistors are very fast and capable of providing nearly instantaneous output. This phototransistor produce a voltage that photoresistors cannot do. And of course, this phototransistor has also some disadvantages, like they are made of silicon and are not capable of handling voltages over 1000 volts. These phototransistors are also more vulnerable to surges and spikes of electricity as well as electromagnetic energy. Phototransistors also do not allow electrons to move as freely as other devices do, such as electron tubes. Moving to the applications of phototransistor, they are used in computer business equipments for the purpose of write, protect control, floppy driver, margin controls in printers, etc. And also in industrial purpose like LED light source as light pens, security systems. Moving to consumer applications like coin counters, lottery code readers, etc. comes under these phototransistor applications. Moving to another major category, opto-coupler. What is this opto-coupler? It is also an electronic device which connects two isolated circuits by light. Basically, this opto-coupler consists of LED and photosensitive device. Both the circuits are enclosed in a package and the circuits cannot be changed externally. These opto-couplers are used to prevent the system from high voltage. You can see here transmitter infrared LED and receiver photosensor, both are connected for getting the input and producing the output. This opto-coupler, this is the symbolic representation of opto-coupler. You can see the LED at the source side and phototransistor at the detector side, and plastic or heat sink tubing is also given for the light to pass over. An opto-coupler is an electronic component that interconnects two separate electrical circuits, that is LED and phototransistor are connected here by means of light sensitive optical interface. Yes, by using the optical interface, these both are coupled together. And so this device is said to be opto-coupler. Using optical light sensitive device, it couples two different devices. In electronics, an opto-isolator, also called an opto-coupler, photocoupler or optical isolator, is an electron component that transfers electrical signals between two isolated circuits by using light. This opto-couplers prevents high voltages from affecting the system receiving the signal. And commercially available opto-isolators withstand input to output voltages up to 10 kV and voltage transients with speed up to 10 kV per microsecond. A common type of opto-isolator consists of an LED and phototransistor in same package, which we have seen in the previous diagram. And these opto-isolators are usually used for transmission of digital, that is on-off signals, but some techniques allows us with analog or proportional signals. This is the diagrammatic representation of this opto-coupler, which has insulating film or dielectric between the two different devices. An opto-isolator contains a source emitter of light, almost always a near infrared light emitting diode that converts electrical input signal into light, and a closed optical channel and a photosensor which detects incoming light and either generates electric energy directly or modulates electric current flowing from an external power supply. The sensor can be a photoresistor, a photodiode, and a phototransistor, a silicon controlled rectifier, or a triac. Because LEDs can sense light in addition to emitting it, construction of symmetrical bidirectional opto-isolators is possible. Moving to the structure of photocoupler, you can see the structure here. Circuit 1, Circuit 2. Circuit 1 is the source LED. Circuit 2 is the detector phototransistor part. It consists of two circuits which are electrically isolated. The first circuit infrared emitting diode, and second circuit is the infrared sensitive device. It can be photodiode or phototransistor or phototriac, photo-SCR. The space between the two circuits can be made of glass, air, or transparent plastic. The LED emits the light and the phototransistor receives the light and amplifies it. The first and second pins are the anode and cathode of LED. Third and fourth pins are the emitter and collector of the phototransistor. Moving to the principle of optocoupler, the output of electrically isolated circuit is controlled by varying input of the circuit. Input is given through LED by voltage source, and the intensity of voltage source is adjusted by varying the input voltage. The emitted light of a particular wavelength here is detected by the photodetector, and it gets convert the light energy into photocurrent, and the output current produced is amplified, which is proportional to the intensity of the light incident on it. A optocoupler solid state relay contains a photodiode opto-isolator which derives a power switch, usually a complementary pair of MOSFET. A slotted optical switch contains a source of light, a sensor, but its optical channel is open, allowing modulation of light by external objects, obstructing the path of light or reflecting light into sensor. Moving to the advantages of optocoupler: compact and less weight, low cost, works very fast, less noise, and major disadvantages is these are not capable to handle high current. Moving to the applications, these are used for ground isolation, high voltage monitoring circuits, lighting control circuits, dimmer circuits. And some major applications like it's used to isolate two different electrical circuits, used in solid state relays, ground isolation purpose, motor control circuit, switch mode power supply, DC to AC converter in automobile circuits, etc. Moving to the important questions regarding the topic which we have discussed now. Part A, 2 marks. Write a note on phototransistor, give the characteristics of phototransistor, state the application of phototransistor, and write a note on optocoupler, state the characteristics of optocoupler. Moving to the part B and C, 13 marks and 15 marks. Explain the construction working principle of phototransistor, explain the construction symbol and characteristics of optocoupler. Of course, as I have said earlier, whenever you start preparing a topic, you prepare it as an elaborate one, like 15 marks preparation. Then only you can able to write whether they are asking the same question in 2 marks, 4 marks, 8 marks, whatever it is, you can easily make over it and write it very clearly. Moving to the important links for reference, here I have given the website links for the application oriented concept of the topic which we have discussed now, and also corresponding book references, suggested book Electronic Devices, UA Bakshi AP Codes, page number 5th chapter 35 to 38 corresponds to the topic which we have discussed now. Moving to the application part, as we have said, the phototransistor as well as the optocouplers both are used in detection and switching circuits. You can see these optocouplers are used for the purpose of dimmer circuits, light dimmer circuits, and also this phototransistors, which are major implemented in counters, coin counters, readers, and also for writing anything in the printers or floppy drives. So whenever you are going for any light pens in the mouse writing, or else if you are going for any dimmer circuit, this phototransistor and optocouplers are in major used. This is about the topic which we have discussed now. If you have any doubts in this, you can ask me and get the details. Thank you.